Hello guys, let's discuss today's problem, that is maximum bipartite matching. So as let's read the question. There are m job applicants and n job. Each applicant has subset of job that he or she is interested in. Each job opening can only accept one applicant, and job applicant can be appointed for only one job. Okay. Given a matrix G with Ambrose and N columns, where G, I, J denote the ith applicant is interested in J job. Okay, fine. Find the maximum number of applicant who can get the job. Okay, fine. Let's take the input. Okay, fine. Okay, okay. So what the question says, ki there is an m persons. Okay, so m persons and n job. Okay, there is a job number is n jobs. So they are given a matrix which represent the key that ith person is interested in jth job or not. Okay, so here as per the matrix it is like this: 1 1 0 1 1 0 1 0 0 1 1 1 0 1 1. Correct. So 0 1 2, here if you see 0 1 2 3 4. So it's like this ki 0th person is interested in job ID with 0. Okay, first person is interested in job ID with 1 and 4. So first person have two interest in jobs. One is with ID 1 and another is with 4. 0th person interested in job ID 0. 0th person is also interested in job ID 1, and 2 he is not interested as it is marked as 0, and 3 and 4 he is interested. Correct. Similarly 2 is interested in 0 1 and 3 4. Fine, that is understood, right? So let's draw a bipartite graph. Okay, so I'll put person here and I'll put job here. Okay, so I will have three nodes: first node, second node, third node. This represent the persons, and here I have four jobs, right? Zeroth job, first job, second job, third job, and fourth job. Correct. Now coming to this one. So 0th person is interested in job ID 0 1 3 and 4, right? So I am making an age between them: 0 1 3 and 4. Correct. Now coming to the first person, he is interested in only first and fourth job, right? So he is interested in first job and fourth job, correct? Now coming to second person, coming to second person, he is interested in first, zeroth, first, third, and fourth, right? Zeroth, first, third, and fourth. Now here some constants are also they are giving. Some constants also they are giving. Key I can assign a single job to a single person. Okay, that means ki if I assign this job to job 0 to 0, I cannot able to assign 0 job to 3 because he is also interested, right? He cannot able to have that. So if he does not have that, he has an option to take either 1, 3, 4, right? Among them he can choose any of them, but he can't able to choose 0 because 0 is already chosen by 0th%. It's given to 0th%, correct? Right now we need to find the maximum job I can assign. Okay, so let's say here in this example, let's say I assign this job to 0, then 0 I cannot able to assign this job to 2 again. So I'll write 0th job is assigned to 0. So other vertices, like if 2 is added, I'll remove this vertices, correct? Because I cannot able to assign. Now again, if for one is interested in first job and fourth job, right? So let's say I'll assign him the fourth job. So one is assigned with fourth job. So I'll remove this 1 to 1 because he is already assigned, right, with fourth job, and fourth job is attached to the 0, but 0 is already assigned to 0 job, so it's fine, correct? Now second have the option of is it having any option of yeah. So second have the option of 1, so I can assign only first job 1 to the second. So total second will have the option of 1. Okay, so total I can assign okay, I can assign 3 jobs, correct? So my answer will be 3. Now assume ki 0th% having the 0th job, correct? 0th% having the 0th job. Then other person who is attached to 0, he cannot able to select that 0 because 0 is already assigned. Okay, now for example, let's say so I'll write an function. So we need to keep in mind ki if the jobs are already visited or not, visited or not. So if visited, job I is visited, we pass on, we continue the process because it's already assigned. Okay, assigned, correct? but if that job is not visited, visit of I is equal to 0, job is not visited, then obviously we can assign that. Okay, but we have to also check कि that job is assigned to somebody else or not. Okay, it's already assigned कि है कि नहीं, we need to check. So I need to check कि assigned of J is already assigned or not. Okay, so if it is assigned, correct, if it is assigned, or then we can do anything, correct. If it is not assigned, let's say it's some value, then we can give him, right, assigned of J, we can give it to I person, correct. But there is a possibility कि if it is assigned, can we assign, let's say, that jth job, let's say I have jth job, right, it's already been assigned of J, let's say T, it's already been assigned to T, correct. Now if it is not assigned, assigned of, let's say J, if I initialize with -1, let's say. So if it is not assigned, it value is -1. If it is not assigned, then the problem is solved. We can assign that job to I directly, correct. But one more possibility is there, key jo, like, if it is assigned, right, if it is assigned to some T, can there be any other possibility that T is assigned to another job, not J? Let's say, can T be assigned to the kth job or not? If there are some jobs which T is also interested apart from this J job, is it possible? If it is possible, we are assigning that kth job, assign kth job to T, then this J job is free right now and I can assign it to I. Got my point? So let's say here is two-person is there, and two jobs are there, correct. Now let's say one is interested in first job and as well as second job, but two is only interested in second job, correct. Let's say assignment of second job is goes to 1. Let's assume a condition scheme, okay, you have to assign the second job to 1. Now if you check, this is assigned and this is also visited, correct. Now there is no possibility for two to have any job. But if I assign the 1 to 1, job 1, then there is a possibility to having a job, at least one job, correct. So at that situation, we'll try can one have other job also? Can one have the other jobs also or not? Okay, so we'll try try to assign the one another job. So in this case it is possible. Why it is possible? You can see ki one can have the job one also, correct. So at that case we'll assign the first job to 1. Okay, then after coming, then we'll assign the second job to 2. Then there will be maximum assignment. assignment. Correct. Maximum amount. So the count will be 2. So we need to check key if it is j job is not assigned, then directly we will assign that j job to the ith person. If it is assigned, we'll try that the job which j job, the person whom the job is assigned j job, can he have other job also? If it is true, then we are assigning that job, the other job, to the person T, and we are assigning the j job to the I. In this way, we can achieve the maximum assignment. Correct? So keep it in mind. So I will write the function. Let's say the youth person is given, right? Youth person, and we have matrix, right? Grid. Okay. So if I put a function here, and let's say boolean function, it will tell me ki if youth person, if any job is assigned to the can be assigned to the youth person or not. If any job can be assigned to the youth person or not, that is this function will give me. So boolean function, youth person can have that job or not, any job or not. Correct? So here what I have to do, first we need to very clear about that key any person is already visited or not, and also the any job is already assigned or not. Correct? So what I'll do, I'll iterate from 0, say I is less than grid of your dot length, right? And I plus plus. So I am iterating. Now I have to check whether this ith, okay, ith job already visited or not. Because if the job is already visited, there is no meaning, because it's already assigned somehow. Correct? So if visited of I is not equal to 1, correct, or equal to 0, you can put 0 also as job, and or at that particular job he should be interested, right? So grid of u and I should be equal to 1. Correct? If this case is satisfied, first of all I will mark it as visited. Okay, visited of I is equal to 1. Now we have to check key if the ith job is assigned or not. If it is not assigned, that I will initialize it with -1. If it is not assigned, then we can assign it. Correct? Assigned ith job with you. Correct? Youth person. And we will return true, because we can able to assign a job to the youth person. Okay? And or another condition, what if the I job is already assigned, and that assignment, okay, the assigned person can have other job, can he able to take other job, and he can leave this job or not? Okay, so that the youth person can take his job. Okay, can we assign the occupied job person to another job? So the job ID is I. If let's say this, if this is not equal to -1, then obviously some person is already having that job, right? So with that person, can he have another job apart from this job? Okay, so we need to check. So what we have to do, we need to take function of assign job of I, and we need to send the grid. So this function will tell me ki he can have other job or not. Now you can ask ki how let's say this person can have the same job also, right? I job. But if you see, I is already, when he goes in this function, right, I is already visited. So it is like filter out there only. He will not have this job. Apart from this job, if some other job he can have, he'll take it. Correct. So in this case, we are returning true. Key we can assign. Correct. Now, if this is not possible, we are returning false, because no job is assigned to the youth person. We can't assign any job to the youth person. Fine. Fine. So this is the basically the logic. Now let's code it. I'll put it grade. That is more feasible for me. Okay, I have to take two matrix, visited matrix and the assigned matrix. Assigned matrix, correct. Now I have to take the length m is equals to grid dot 0, correct. Now I'm taking the maximum maximum value of n and assignment. I am initializing the assigned equal to int width and filling it with -1. Okay, fine. Filling it with -1, that's fine now. Now I'll write the function, a boolean function, okay, which usually take the integer and the grid. Okay, now I'll check I is equal to 0 to I is less than grid of u. Why grid of u? Because we are trying to ask the job for the youth person, right? So I am taking grid of u. So assignment, the data for the assignment will be present in the grid of youth row, right, for the youth person. So if that is not visited and this person having interested in that job, correct, then only we are going inside. Okay, making it one visited. Now I have to check if it's already assigned, either the job is already assigned or not. If it is not assigned, then I can assign it assigned it to youth person, correct, and return true, correct. Now there is a possibility ki it's already assigned. Then we have to check ki the assigned person to the I job can have other job or not. If we can have other job for him, I can assign the I job to the you, correct. So I'll check ki assigned of I job can have the other job or not. Okay, if it is not possible, then we will return false. Correct? Fine. Now we have to calculate. I have to calculate what? Answer, right? I am iterating from I to grid dot length, right? Which represent the what do you say? Rows represent the person, right? I'm iterating over the person, and initialize visited array. Visited is equal to new int of n, and initialize array start fill visited array with 0, right? Fine. Now I have to check if I can assign, that what do you say, what ith person. Okay, the ith person, if I can assign the ith person with any job present in the grid, then I'll do put answer plus plus. Okay, I can able to assign. Now return the answer. That's all. Hope you got that. Let's compile this first. Okay, so it's coming correctly. Let's submit this. Yeah, hope you understand this one. Please like and subscribe my channel, and we'll meet in the second video. Thank you.